All right, well, welcome to our week 8 live lecture series. I should have updated these times on here, but this week is a little bit different schedule-wise than the rest of them, but you should be hearing audio right now. If you are not, you can check the volume of your computer and check the settings in Zoom under audio settings. If you have issues, you can contact the Zoom tech support line at 1-888-799-9666 extension 2. And you do not need to have a webcam or microphone to participate today. You can use the chat feature in your Zoom controls, or you can use the reactions to raise your hand also from the Zoom controls. And if you wanted to ask audibly, you can unmute after raising your hand to do that. All right, so this week we are, get my screen correct here, reviewing for your final exam. And so you have some prep material in your course that is designed for your final exam. You had some review homework, I think probably last week, and a prep quiz, and then probably this week, or maybe it's all in this week, I forget. You also have a practice test. I highly encourage you to do that, particularly the practice test, not only because those things are included in your grade in your course, but they are designed to help prep you for the actual test. So if you can do well on the practice test with those types of problems, then you are probably well prepared for your actual exam problems. But we also created a study guide that you probably saw in 2 different places. Your instructor of your specific course probably posted it in an announcement. And then also you probably received an email that we had sent to all Math 136 students that had that. And so that should have looked like this. And it included just the sections that are on your final exam. The final exam is not cumulative in the sense that we go back to sections from the midterm material to put those questions directly on the test. However, it is cumulative in the sense that you still need to know the skills from those sections because they carry through the entire course. And so in that way, it's cumulative, but there are no specific questions that came from anything before section 4.3. So just very briefly, I really recommend you take a look at this study guide. If you haven't, maybe use it as a study guide checkoff list as you're studying to say, yep, I know this. I'm good on that section, or, oh, no, let me highlight or circle this to come back to study this item because I don't remember that so well. So you can see it's separated by section and type of objective. We've got important tips and reminders on here. Anything kind of in italics kind of is a tip or reminder calling out something that students maybe often forget. And then there's page numbers to refer you back to specific things in your e-text where you can go look up examples and more information on that if you've forgotten everything. So it's primarily section 4.3 and 4.5, and then from chapter 5, sections 5.5 and 5.6, and then the rest of it is chapter 6. So you started in section 6.1 all the way down through section 6.8. Okay, and so that is the specific content that is on your exam. So what I have prepared today is a set of review problems that the live lecture team selected to help prepare you that are similar to your exam questions and similar to your practice test questions. They're not the exact questions because again, those are graded assignments that you're working on, but these are similar. So what I did, there's 20 questions here. Your test is 20 questions. And what we did is we pulled a set of 20 questions similar to that. And, you know, we only have an hour now, 55 minutes to discuss things. So we're not going to get through everything. So if you're here live and you have a specific area or section in the course, you know, back from, you know, section 4.3, 4.5, 5.5, 5.6, anything in chapter 6 in those specific sections that you struggled with, feel free to put that in the chat and say, you know, I'd really like help on section 6.7, or I'd really like help on section 6.5. Feel free to do that. Otherwise, what I'm going to do is I kind of ranked these questions in order of most missed type of questions from past Math 136 online students. So I took a look at we took a look at our courses and said, okay, what have students struggled with in the past? Because that's typically where we're going to continue to see students struggle now. And so I'm going to go in that order, the ones that were most missed or skipped by students, and then see what we have time for. I will get through as many as I can. But again, if you've got questions, put it in the chat or raise your hand in the Zoom controls, and I'm happy to tailor this to you as one of the live attendees. So I'm going to start near the bottom of my list, because those tended to be the questions that were, again, most missed or skipped by students for various reasons. And one of those is this question 19 that I have prepared here. This question 19 is from section 6.8. So this is something recent that you guys have done, and this is with growth and decay. And so on this number 19, we are going to look at an insect population. And in that insect population, it is following this formula for growth. So we've got P of T is 900 times E, our base, raised to the 0.02 T. And so we've got multiple parts here. So that's another thing when you're working on the exam questions. Remember that you do have multiple parts. I like to make a note for myself of any special instructions. So I see here, we're going to round answer C to the nearest whole number, but we're not going to round to the final answer. And then on question D, we're going to round to the nearest 10th. And again, not rounding until the final answer. And then likewise for part E. So there's multiple parts. And again, you get partial credit, so you should be showing your work for your instructor in case any one of these parts is incorrect, but you've got some correct work on your paper. They might review that and give you some extra points back for what you do know, as opposed to the computer just, going by the final answer. So it says determine the number of insects at T equals 0 days. So there's two ways to do this. You could do P of 0 and figure out what that equals if T equals 0, or remember that P naught, and I'm using P because that's the function they gave us, but I think on your formula sheet, they actually give you like N of T equals N naught times E to the KT. But that is your initial quantity or value. So I don't even have to plug in 0. I just know based on the format of the equation that they gave us that 900 is that initial amount at time 0. But if you did plug in 0 for T and you did evaluate that with a 0, you would get the same answer of 900. But again, time is precious at your test sometimes. And so if you know instantly that, okay, that N sub 0 or P sub 0 is your initial quantity, you can just go right to that answer. Now, part B, I think sometimes students miss this because they don't interpret this correctly. It says growth rate. What is the growth rate of the insect population? So again, your growth rate is the K in your formula, or in this case, the 0.02 that's in front of the T. However, this is where I think students often get this question wrong. Notice that it has a percent sign. So in the formula, you want to change the decimal to a percent before entering your answer. Okay, so remember, anytime you calculate with percentages in equations and formulas, you convert that percentage to a decimal equivalency. And so that's what the 0.02 is. So the 0.02 is really 2% when you move that decimal point over 2 places or multiply by 100. So you would be putting in an answer of 2 in that blank and not 0.02. So I've seen students get that wrong before because they put in the decimal. That is something that would be at the discretion of your instructor in terms of, is that worth partial credit or not? Yes, they kind of identified the correct portion of the formula, but they didn't enter it as a percentage. Some faculty might say, no, that's something they should know and we're not giving partial credit. Other faculty might be more lenient and say, yeah, let's give them maybe half credit or, whatever. And that's where, it varies per class and per instructor. and rightly so. It really is something that can vary even in campus courses and not necessarily just the online courses. So then part C says, what is the population after 10 days? So after 10 days. So that's basically saying find P of 10 if T equals 10, okay? And so in that case, we would be taking this calculation, and I'm going to scoot over here and say P of 10 is 900 times E as our base raised to 0.02 times 10. Now, when I go to put this in the calculator, I'm either going to go ahead and put parentheses around that product of 0.02 times 10, or you can pre-multiply that and just say, you know what, I'm going to enter this as 900 times e to the 0.2 because we've multiplied the 0.02 times 10 to get 0.02. And so again, in your calculator, you're using your e to the x key. Your e to the x key is most likely after you hit a second and then ln for natural log key, depending on the brand and type of your calculator. So you would enter 900 times and then do your second ln to get the e to the x and then put in the 0.2. Some calculators will put in a parenthesis. So if you open a parenthesis, close the parenthesis. So again, a lot of times I see students make mistakes because they just simply can't use their calculator correctly, but they have the correct information on their paper. So again, partial credit is a wonderful thing for students. If you've got this information on your paper, you wrote the equation, evaluating at P of 10, you put the 10 in the right place, you have what I have here in purple on the screen on your paper. Most faculty, again, it's at their discretion, would give some credit for that. And then we can see that, oops, you went wrong in the calculator because your answer in the blank isn't correct. But if you put that in correctly, you should get 1,099 insects when you get that rounded to a whole number. So that's the other thing you want to make sure your rounding is done correctly as well. Then part D says, well, when will the population reach 1350? So when is indicating, what is the time frame? And the 1350 is the future amount at that time frame. So that's P of T. So this means that I've got 1350 equaling 900 times E, 0.02 T. And I need to solve for T. And so this is a good review of solving exponential equations just in general. So you want to isolate the base E raised to the exponent. So I would divide by 900 on each side. And 1350 divided by 900 isn't going to divide equally, but I can certainly simplify that by dividing out a power of 10 of each one and get 135 over 90. It just makes the numbers a little bit smaller for me to work with, equaling e to the 0.02 t. Now, at this point, you have two different options, and it really depends on your preference. You could, at this point, use the definition of a logarithm. Remember that y equals log base a of x if and only if a to the y equals x. So right now, this is written, our equation we're solving is written in exponential form. That's like what I have over here on the right side of this definition. We could switch it to log form, which is like the left side of this definition. Or this is my preferred method, but again, using the definition works fantastic also. Or I could come in here and apply the natural log to each side of the equation. And by doing so, the natural log, which is base E, of base E raised to this power, those kind of negate each other because of their inverse properties and just leaves us with 0.02 t. So this turns into, down here, the natural log of 135 over 95 equaling 0.02 t, which brings that 0.02 t out of being in the position of an exponent. And now to solve for t, you just divide by 0.02. So your final calculation that would go in your calculator is in the numerator, the natural log of this fraction 135 over 95 divided by 0.02. And that would give you t, and you would just take that final answer and round to the nearest tenth. So if you do that correctly, you should get 20.3 days, rounded to the nearest tenth there. And then part E is a variation of what we just did in part D. It says when, So that's a time. So that's still finding T. When will the insect population double? So that's telling us that P of T is twice the initial amount, P sub 0. Well, the initial amount was 900, so then double that is 1800. So that's basically solving 1800 equals 900 times e to the 0.02 t. And notice that is very similar to what we just did up here, that instead of 1350, we now have 1800. So you use the same steps, as part D. It's just you have different numbers. So to save time, to get to more review problems, I would just walk through the same thing. I'd have 1800 divided by 900, which would be 2. So instead of 135 over 90, I'd have a 2. I'd take the natural log of each side, and then I'd end up dividing by 0.02. So after I follow all those steps, T would be the natural log of 2 divided by 0.02. And that's what I would be putting in my calculator and rounding to the nearest tenth. And in doing so, I'd get 34.7 days. Okay. So D and E are very similar with that. Okay. And again, I encourage you, if you have any questions, feel free to put them in the chat or raise your hand, and I'm happy to answer any of that. But that's, again, a common missed problem. I think another commonly missed problem is this number 20. And so for this number 20, this one is also from section 6.8. And again, I think it might be a combination of either calculator issues or just not using our log properties and exponential properties correctly is why these types of questions are most missed. But this appears to be a decay problem. We've got strontium 90 that is a radioactive material decaying, and they give us this equation where, again, that A sub 0 is your initial quantity that you have present, and time is in T. And it looks like the scientist is starting with a sample of 400 grams. So I would say that this equation then is A of T equals 400 in place of A sub 0 times E to the negative 0.0244 T. So remember, when you have a decay problem, the K value is negative. That's how you know whether it's growth or decay. So first question is, it says, what is the decay rate? So again, as soon as you see rate, remember, change your decimal, negative 0.0244, to a percentage. So decimal to percent. So I can move my decimal point 2 places to the right, or that's basically multiplying by 100. And that tells me that this is negative 2.44%. And then pay attention to the instructions. It says type an integer or a decimal. This is a decimal. And include the negative sign for a decay rate. But they already have a percent sign there, so you don't need to enter that. So I would include the negative sign and then 2.44. Okay, so I think sometimes students don't put the negative sign in, and that might be why they get this wrong. Then on part B, extra instructions here, round to the whole, nearest whole number, but don't round until the final answer. We want to know how much strontium 90 is left after 10 years. So basically that means find A of 10 if T equals 10. And so taking our equation, A of 10 is 400 times E to the negative 0.0244 times 10. So again, if you're going to put this directly in your calculator all at once, which is recommended, that's the beauty of a scientific and graphing calculator, is that it can handle one big calculation at a time, and you don't have to do it in multiple steps. I would encourage you to make sure you've got parentheses around that product of negative 0.0244 times 10. If you want to pre-multiply that, again, that is negative 0.244. So instead, you could be entering A of 10 is 400 times E to the negative 0.244. You would still have that in parentheses, but you wouldn't have to have it times anything in there. It's just one number. But by default, most calculators, when you type E to the X, it's going to put in a set of parentheses to open it. Now, the other thing is this is a negative sign, not the subtraction key. So on your calculator, you probably have a button that looks like that. It has a dash that looks like a minus sign, but with parentheses around it. It's usually located sometimes near the bottom of your answer, your number keys, but it depends on the brand and type of your calculator. But the subtraction key doesn't have the parentheses, and it's usually with your division key, your product key, and then your minus key, and then your plus key. That is the one you don't want to use. You do want to use the negative sign key, which again is somewhere else on your calculator. It varies on type and brand. So make sure you're using that key and not the subtraction key. Otherwise, you will get the wrong answer when you enter that. So you enter that into your calculator appropriately. And when you do that with the appropriate rounding to the nearest whole number, you should get 313 grams. Part C, again, looking at rounding instructions, nearest tenth, but don't round to the end, says up here, when will only 300 grams of strontium-90 be left? So when it says when, that's basically find T. When 300 grams is left, that's when A of T is 300. So I'm going to do this one down here. That means 300 is what this is all equal to, which is my equation 400 times e to the negative 0.0244 t. And so we have to solve for this t. So this is, again, similar to this solution process here. We're going to divide on each side by the coefficient that was the initial amount. Then we're going to either apply the natural log to each side, or we're going to use our definition to switch from exponential to log form, and then proceed from there. So I can take 300 divided by 400, which I can simplify to 3/4. If you want to write that as 0.75, you can. I would not write it as a decimal if it did not terminate. But since 3/4 does terminate as 0.75 and no continuing digits, you know, I'd be okay with writing it as 0.75 instead of the fraction. E to the negative 0.0244 t. Now, I'm going to write this one as if I was doing the definition. So y equals log base a of x if and only if a to the y equals x. So right now, what we have is, in place of a, we have a base e. And in place of y, we have negative 0.0244. And then in place of x, we've got 3/4. And so if I'm going to switch that into log form, then I'm going to have what was y, which is the negative 0.0244. I forgot my t. There it is, t. Equaling log with base a. Well, log base a in this case is base e, but we wouldn't write that as base e. We would write that as natural log. And of x, the x was 3/4, so natural log of 3/4 or 0.75. So that's what this turns into. So if I'm using the definition, I could just turn that directly into negative 0.0244 t equaling natural log, and I'll go ahead and write this as 0.75. Okay, so that's just showing you if you did that as opposed to taking the natural log of each side, it equates to the same next part of the equation. It's really your preference which way you kind of see that. So then I divide by negative 0.0244 on each side, and this is what I'm putting in my calculator. Natural log of 0.75 divided by negative 0.0244. Again, making sure that you're using the negative key, not the minus key for that negative value there. And so then rounding to the nearest tenth, we would get approximately 8.8, or sorry, 11.8. And so we get 11.8 there, okay? All right, then D is taking us to what is the half-life of strontium-90. So we're rounding to the nearest 10th, not rounding to the n. And so half-life, you have to think about what that means. Well, as opposed to the growth problem where maybe we're doubling something, half-life means half of the initial quantity is left. So we started with our initial amount being 400. So therefore, half of that is 200. So basically, we need to find T when A sub T is 200. And were we? Yeah, we were using A. So when A sub T is 200. So we're going to take 200 equaling 400 times e to the negative 0.0t 44, or negative 0.02, excuse me, 44t. Now, this again, to save time here, we're going to follow the same steps as previous part. You can either take the natural log of each side after you divide by the 400, or you can use the definition to switch from exponential to log form. Put that all in your calculator. You'd be getting t is equal to natural log of a half, or as it terminates, I'll write that as 0.5 divided by negative 0.0244. And that's what you should come down to and have as what goes in your calculator, and then round it to the nearest 10th, and you get 28.4. That would be our answer up here. So again, the solution process is the same. You just have to interpret what it means by half-life on that one, okay? All right, so then another commonly missed type of problem is something like this, number 17. And this is from section 6.7. And this is asking you to find what rate of interest. So that would be finding R for your rate of interest compounded annually is required to double an investment in 19 years. So I want to break this down. So rate of interest would be R. Compounded annually is going to tell me that N is 1. So N is the number of times your amount of money is compounded where the interest is calculated. And then required to double an investment. So if I'm doubling an investment, we have to think about what that means. Well, your initial investment is P for your principal. So to double means your amount would be double your initial, so twice P. And then you are going to do this in 19 years. So that's telling you T equals 19. And so you have to figure out what formula are you using? Well, because it says compounded annually, then that tells me I'm using the compound interest formula. A equals P times 1 plus R over N raised to the N times T power. So I can see what do I have to plug in, and then what am I solving for? So A is twice the initial investment. My initial investment is some amount P times 1 plus my rate, which is what I'm solving for, divided by N, which we know is 1, raised to a power of 1 times 19 for the number of years. So if I simplify this a little bit, R divided by 1 is just R, so this is 1 plus R. And 1 times 19 is just 19, so I have a power of 19. And then I can divide by P on each side. And if I do that, divide by P, those go away. So really I just have this 1 plus R to the 19th power equaling 2. So I need to solve for r in the equation 2 equals 1 plus r to the 19th power. So I could do this 2 different ways. To reverse the 19th power, I can either take the 19th root, so I can have the 19th root of each side, to reverse the 19th power, or I can look at this as raising, let me do this in a different color, each side to the 1/19th power, because by raising that to the 1/19th power, by the power rule of exponents, 19 times 1/19th for the 2 powers equals 1, which again gets rid of that power. So again, either think of it as taking the 19th power or taking the 19th root, or taking the 1/19th power. If you don't know how to use your calculator very well with roots other than a square root, because most calculators by default come with a square root key, but they maybe have it more, it's harder to find how to do other types of roots, I would stick with the power of 1/19 because that just uses the caret key. And then using the fraction 1/19 as your power. But you can do either one. But if you're going to use your calculator for the 19th root, you're basically usually looking for a key on your calculator that looks like this with an x root, or it might say nth root. Again, different brands of calculators, Scientific, Graphene, TI versus Casio, do things in different ways. So it depends on what you have. But if you were going to use the 19th root, you probably hit 19 first, then you hit your key for the type of root, and then you put in 2. But if you were doing this in your calculator with the 2 to the 1/19th, you would just be using your caret key. So I would put in 2, caret key, parenthesis, 1, divide by 19, close parenthesis. So that's quicker and easier, and an easier set of buttons to find on the calculator. So you would do each of those. The 19th root gets rid of the 19th power, 1/19th power gets rid of the 19th power, but then you're still left with either the 19th root of 2 equaling 1 plus r, or, I'm going to squeeze this in here, 2 to the 1/19th power equals 1 plus r. So you still need to subtract 1 from each side. So subtract 1, subtract 1. So ultimately, what you're entering in your calculator, I'll write it over to the side here, is either the 19th root of 2 and then minus 1, or 2 raised to the 1/19th power and then minus 1. That's what you put in your calculator. Make sure that in each case, the square root, the 19th root of 2, you probably have to close this parenthesis after the 2 before you hit minus 1, and make sure that you're not putting the minus 1 still underneath the 19th root. And then same thing with the raising to the 1/19th power. You want to close this parenthesis after the power of 1/19th before you do minus 1, so you get this done correctly. Either way that you enter that into your calculator, we're going to pay attention to the rounding instructions. Notice it says percent for the rate and round to 2 decimal places. So because this is solving in the equation, we're going to get a decimal first. So if I want the rate to be 2 decimal places, and to convert to the percent rate, we would have to multiply by 100. I want the decimal, let me rewrite that, that's very sloppy. The decimal to be 4 decimal places. So if I put either of these in my calculator, I should get the same thing. Into 4 decimal places, I get 0.0372. So that now to switch to my percent, by either multiplying by 100 or shifting the decimal point 2 places, this is 3.72%. And it's the 3.72 that's going in my answer blank into MyLab. So that would be our answer here. Okay, so this one's a little tricky because I think of the unusual type of root or power, and then also because you have to remember that when you're solving for r in the equation, it's in decimal form, but you need to convert it to rate, which is a percent form for your final answer. Okay. So again, feel free if you've got any specific questions to put that in the chat or to raise your hand in the Zoom controls, and I'm happy to answer any of those specifics. So then I'm going to go on to number 16. Again, what I'm doing is going by past classes that I've had of online 136 students and what were the types of most challenging problems or missed problems or skipped problems related to this type of content from their final exam. So I am basing this off of former students and what I saw the most in those classes. So number 16 is solving an exponential equation. And excuse me, this is from section 6.6. And so in section 6.6, you're solving exponential or logarithmic equations, but you're also using different properties of exponents and logarithms. So I'm going to pay attention to the instructions here first. It says we're solving this exponential equation. We're going to express any irrational answers or solutions in exact form. That lets me know that if I've got something that might have a log as part of the answer or a natural log, I'm going to leave it in that log form, and I'm not going to put it in my calculator to get a decimal. Notice there's no rounding instructions here. So when I look at answer A, if there is a solution versus answer B, if we find there's no solution, it just says to simplify our answers, use a comma to separate multiple answers, use integers or fractions, type an exact answer, including any radicals that might be needed. So this means no decimals, and that means no calculator, most likely, okay? So that's another place where I see students sometimes make mistakes with that. So let's look at what we have. We have 4 to the x plus 2 to the x plus 1 minus 1 equals 0. So that looks a little complicated. We're solving for x, it's in the exponent, but it's in 2 different exponents in 2 different ways. So this one requires a little bit of thinking outside the box, but not so far outside the box that it's not something you shouldn't know how to do. I'm going to rely on exponent rules. Let me write that more clearly. Exponent rules and U substitution. Okay, so what I see is I'm going to rewrite 4 with a base of 2, because right now I see I've got a base of 2 and a base of 4. I think it'd be easier if I had the same base. So note 4 is 2 squared, right? So I'm going to rewrite this equation as 2 squared raised to the x plus 2 raised to the x plus 1 minus 1 equals 0. So I've made that substitution, okay? What I also see is, because of my exponent rules, instead of writing this as 2 squared raised to the x, I'm going to swap that around and say this is 2 to the x squared, because my power rule for exponents says that I would just multiply the 2 and the x anyway that I have as exponents. So by the commutative property, I can swap the order of those around. And so 2 to the x squared is the same thing as 2 squared raised to the x. And then I'm also going to notice that by having an exponent of 2 to the x plus 1, also relying on my exponent rules, I know that that's the same thing as 2 to the x multiplied by 2 to the first. Because by our product rule for exponents, because these have the same base, I would add the exponents x plus 1 and just keep the same base, which is what we started with as 2 raised to the x plus 1. And then I have minus 1 equals 0. So now I'm going to take a look at that, and I'm actually going to move this 2 to the first in front, and I'm going to stop writing it to the first power because it's I don't need to write it to the first power. And I see this as 2 to the x squared plus 2 times 2 to the x minus 1 equals 0. And so where this u substitution is going to come into place is I'm going to say, I'm going to let u equal 2 to the x because I see 2 to the x in the first one being squared, and I see 2 to the x in the middle term being multiplied by 2. So what I really have here is u squared plus 2 times u minus 1 equals 0. And this is quadratic in form. So I want to try to solve that for u, and then I can come back and resubstitute to solve for 2 to the x. So I would look to see if I could factor that. If I try to factor this, u and u, I need a product of -1. So one of them has to be positive, one of them has to be negative. But I need to add the 2 that's positive, so that's not going to work. So then I go to our quadratic formula. So x is the opposite of b plus or minus square root of b squared minus 4ac all over 2a. This is what I was talking about at the beginning, how your final exam is not literally comprehensive in that, or cumulative in that we're taking questions from the first half of the course and putting it on the final, but that the content you learned makes the exam comprehensive because you're going to need to rely on things you learned in the first half of the course to do the second half. And this is a perfect example of that. All the exponent rules that I'm using, and now the quadratic formula that I'm using in solving a quadratic in form, those were things that were in the first half of the course, but here we are using them in order to do these types of problems. So that means b is 2. So I'm going to have x equals opposite of 2 plus or minus 2 squared minus 4 times a, which is 1 in front of the u squared, times c, which is -1 as my constant, divided by 2 times 1. And so continuing with simplifying that, x, or actually, I'm solving for u, aren't I? So I wrote x because that was the formula. U is equal to -2 plus or minus, let's see, underneath the radical, 2 squared is 4. 4 times 1 times -1 is -4, but I'm subtracting -4, so I'm adding 4. So 4 plus 4 is 8 underneath the radical. And then dividing by 2. I can simplify the square root of 8. So this is -2 plus or minus 8 is 4 times 2. Square root of 4 is 2, and then still radical 2 underneath. Divided by 2. They all have a 2 in common. So I can simplify this to -1 plus or minus just square root of 2 for u. So u represented 2 to the x. So this now tells me that either u is -1 minus square root of 2, or u is -1 plus square root of 2. U was 2 to the x. Oops, 2 to the x. So I'm resubstituting, and I'm solving 2 to the x is -1 minus square root of 2, or I'm solving 2 to the x is -1 plus square root of 2. Okay? We're almost done. Some of these problems take a long time. So this is an exponential. 2 to the x equals this whole amount, -1 minus square root of 2, or 2 to the x is this whole amount, -1 plus square root of 2. If you remember your exponential functions, and the easiest way is think of a graph, the output or range of an exponential function is that they're from 0 to infinity, nothing negative. Well, -1 minus square root of 2, that whole thing, that whole amount is negative. So 2 to the x equaling a negative amount has no solution. It won't work, okay? But 2 to the x equaling -1 plus square root of 2, that's a positive quantity. If you don't know that, just put -1 plus square root of 2 in your calculator and you'll see that it's a positive quantity. So this will have a solution. So how do we solve that? Well, same thing as what I was talking about before in my other examples. I could either apply our definition of a logarithm, or I could apply the natural log to each side. If I use our definition to convert to log form, then I have 2 to the x, so my base is 2. So I would, again, my definition, I'll keep rewriting it because it's something you guys should have memorized. A to the y equals x. So my base is 2, so I'm going to have log base 2 of -1 plus square root of 2 equaling what was my power, which is x. And so I'm taking log with base 2 of the input -1 plus square root of 2. That should be our solution, except we're going to go back and look at the directions. Express irrational solutions in exact form, simplify our answer, type an exact answer. So when you have answers like this, that is a log with a different base, that's not just your common log or your natural log, this is not simplified yet. You want to use your change of base formula to write this in terms of probably natural log. And that would be natural log of the current input, which is -1 plus square root of 2, over the natural log of the current base. And so this would be the exact form that you enter into MyLab in the answer blank way back over here. So you'd select A, and that's what you would put in for this answer here. If you don't remember your change of base formula, that should be, I believe, on your formula sheet. If I pop over to your formula sheet, there's your change of base formula. Okay, that's what I utilized. But notice that definition of switching from exponential form to log form that I've used a few times now is not on this sheet. So that's something you want to make sure you know if that's how you're going to use that. Okay. Okay. So that's how I would do that problem. So again, that was a little bit lengthy, but that is the type of work sometime that some of these problems take. And I see there's a question. Other forms of compound interest. So I've gone over so far finding a rate of interest. I've gone over using a growth problem with exponential base E and solving with natural logarithms. I've gone over a decay rate problem. And I can address any individual questions at the end. We've got about 10 more minutes left, but I don't know if anything that I've already gone over, and if it's a calculator issue, I can help individually as well for that. All right, so then let's see, I did 16. And again, if you've got specific problems and not just like, I need calculator help, like, I'm happy to do over different types of problems as well, but it sounds like the question that I'm getting is maybe a specific, let's help you with your calculator type question, which I'm happy to do at the end, no problem. But if you do have specific ones, either topic wise, give me a section, and I probably have a similar problem on here, feel free to add that. Otherwise, I'll keep going kind of in the order that I was going, but feel free to throw more things in the chat as needed. So the next type of problem, unless anyone puts something specific, for a type is number 15. So this is similar to the one I was just doing. It's from section 6.6. It's solving an exponential equation, writing our answer in exact form. So I'm going to say this is probably similar to, let's think about, what do we know about exponentials or exponential form equations, and what can I do? So I can do this a couple different ways. The way I see it, and again, there could be more than one way to do this. So if you ask me how to do it, and then you ask your instructor how to do it, but then you ask a tutor how to do it, we all might come up with a different explanation because there's often more than one path to the answer. And that's what we're trying to teach you. By the end of the course, you guys should have like what I call a whole toolbox of options of ways to solve equations. And so what one person does may be different, but we should all get to the same answer in the end, regardless of the tool that we use. But what I see is I've got two sides of my equation that each has something with a base, but the base is not the same. If the base were the same, and I had, say, a to the u equals a to the v, well, then I can drop those bases and set the exponents equal. But I don't have the same bases, so I can't use that. And it's not going to be really easy to write a 5 as a base 3 or a 3 as a base 5. So that's not going to be easy either. Whereas in this one down below, I could easily rewrite the 4 as a 2 squared. So when that's not the case, what I like to do is utilize our property that says if m equals n, then log base a of m equals log base a of n. In other words, I apply a logarithm of each side, and the specific logarithm I apply is natural log. So I'm going to apply the natural log to each side. And what that does is it allows me to utilize some exponent rules. So the power rule for exponents, which I just had the formula sheet up, so I'll mention it. The power rule for exponents allows us to take what was a power and put it in front as a product in front of the logarithm. So I'm going to utilize that here. I'm going to take this power of 1 minus 2x and this power of x, and I'm going to bring both of those out to the front. So this is going to become the power that used to be 1 minus 2x is now a multiplier in front of 1 minus 2x multiplied by the natural log of 5, equaling this x that used to be an exponent but is now a multiplier out in front times the natural log of 3. And now I don't have to worry about x being an exponent anywhere. It's all in line with the rest of my equation. So it's going to be easier to use things like distributive property, add and subtract terms from each side, and use those equation solving properties a little bit easier than dealing with how the heck do I solve for an exponent that has a variable in it. So these properties allow us to get those variables out of being an exponent. So what I see here is we need to solve for x. Whoops, it's supposed to be a highlighter for x. So right now it's multiplied by natural log of 3, and it's also in this expression 1 minus 2x multiplied by natural log of 5. I'm going to take this natural log of 5 that is just a number. That's what natural log of 5 represents. It's just a number. And I'm going to distribute it to this binomial of two terms, 1 minus 2x. So that's going to give me natural log of 5 times 1 is just natural log of 5 minus 2x times natural log of 5 equaling x times natural log of 3. So now the terms that have x are the minus 2x times natural log of 5 and the x times natural log of 3. I want to get those together. So I'm going to add 2x times natural log of 5 to the other side to collect terms with x to the other side. That's going to give me natural log of 5 on the left equaling x times natural log of 3 plus 2x times natural log of 5. Now I see I've got x in the first term and x in the second term that are added together. So that is in common. So I'm going to factor out that common x, leaving me with the rest of the factors that aren't in common, which out of the first term is natural log of 3, and in the second term is plus 2 times natural log of 5. And this is all equal to natural log of 5 on the left side. Now, because x is multiplied by all of that, I'm going to divide by that expression that we factored out, natural log of 3 plus 2 times natural log of 5 on each side, which gets rid of that and solves for x. So that should be our final answer that goes in option A in this blank. And I would enter it just like that. I would put in a fraction. So you could use that math palette button that looks like a fraction. Put in the top, natural log of 5. Put in the bottom, natural log of 3 plus 2 times natural log of 5. That's in exact form and is an irrational solution there. Okay. I think I might have time to squeeze in one more problem, which my next problem was right above this, number 14. And so number 14 was working with logs and solving a log equation. And so this is also from section 6.6. So there seemed to be a lot of stuff with 6.6 and 6.8, okay? So there's a question about, are there multiple correct answers for these questions? Sometimes yes, sometimes no. So I know it's really hard to interpret, what is exact form and is your answer simplified enough? Did you get an exact answer? Basically, I would say when you're dealing with logs, and that's log with any base, common log, or natural log, try and write your answer in terms of natural log unless the problem is about common logs. If the problem starts with common logs, then leave it in common log. But if anywhere in the problem you had a log with a different base, end your answer by using the change of base formula to put it in terms of natural logs, and then that should be the exact form of the answer. And again, your teacher is going to grade things for partial credit and use their discretion to say, did that student really have an equivalent answer? And then the form might not matter as much, but that's my tip, is get it in terms of natural log, and that way you should pretty much almost always be guaranteed to have it in the correct form. Now, on this particular one, let me scroll back over, you could have had in the denominator 2 times natural log of 5 plus natural log of 3. In the order that you put those in the denominator would not have mattered, and that should have worked and been equivalent. And the computer should have recognized that. But if not, your instructor should recognize that. And again, it's their discretion to say, hey, is that really full credit or is that partial credit? So I hope that helps in terms of like, do these have, multiple ways to answer this? So on number 14, I think I can at least set this one up, if not solve the whole thing. So this one is a log equation. So when you see multiple logs on each side, but there's an extra number added to one of them, then the best way is to try and get your logs together on one side and use your exponent rules. So I'm going to take this log of x minus 3 and I'm going to subtract it to the other side so that I get log of 8x plus 7 minus log of x minus 3 equaling 1. And then I want to consolidate using my log rules, and I see a subtraction. So I know I can put that together as a log of the first input divided by the second input. And now that's equal to 1. Now this is log, which is base 10. So now I convert to exponential form to say 10 raised to the first power is equal to this 8x plus 7 over x minus 3, which is just 10 equaling this fraction 8x plus 7 over x minus 3. So we're out of time, but what I would do is multiply on each side by the denominator to get rid of that. And then I have a linear equation. So I would distribute the 10 times the x and minus the 3, and then collect like terms on each side, solve for x, and I'd find that I have a solution, and I would double check my domain. And this should come out after you take some more steps to a solution of 37/2. So if you want to see for yourself, can you keep going and get that answer? But I want to check domain to make sure that I'm using a valid answer. So remember, for domain, the 8x plus 7 has to be greater than 0, and the x minus 3 has to be greater than 0, because you can only put positive values into a log. That would mean that x has to be greater than -7/8, and x has to be greater than 3. So for both of those things to be true at the same time, anywhere in the problem, x would have to be greater than 3, and 37/2 is greater than 3. So that works as a final answer. So I know I rushed that, but we're out of time. But again, once you multiply on each side to simplify that equation, you should be able to easily get to the 37/2. So if you have any feedback to provide, we would appreciate it. There's a survey that you can fill out. I'm going to copy and put that in the chat, so you can just click on it if you want to. And the recording of this will be made available. And we have other sessions. So depending on when you take your exam, we have other sessions that I want to get the times right for the rest of the week. I have to get to the right thing. Here it is. I think it's tomorrow at 10 a.m. Eastern. And then Wednesday, I want to make sure. I apologize. Yes, it's tomorrow, Tuesday at 10 a.m. Eastern. We have another session. And then our normal Wednesday session, 6 p.m. Eastern. We do not have the Friday and Saturday sessions this week because we moved it up earlier because we know people are testing earlier. So you can get the recording of this at the bottom of this schedule. It's posted in your class. When it's updated, this will be a live link to it. And then here's a link to that survey as well. So we appreciate you filling that out, and good luck on your exam for this week and finishing out your course. Thanks for attending.